This is a recap for Monday, March 8th. So today we took notes on the video here on the right, which I will start and just show you if you are catching up.
Still searching YouTube for math help? Are the videos from
Sorry
2006
about that.
really?
Alright, so I'm just going to show you a couple of places here. So we got this definition right here, that a scale drawing is a proportional two-dimensional drawing of an object. So you might want to pause and get that in your notes. So today's subject is scale drawings. And then there were some examples, a house or a map or even a small toy. And then the next definition we also put in our notes, or it says it's not really a definition, but a statement, excuse me, that scale drawings can represent objects that are larger or smaller than the actual object. So that's based on the scale. And then we put, you can listen to her talk about this small toy. We didn't put that in our notes, but we did put this example right here of a garage. So I would play it from minute 22 up to about the point where she starts talking about area, about 2 minutes. We are not doing area, but we did put this drawing of a scale drawing of a two-car garage in our notes. And notice how it says 18 inches across the top. This is a sketch of a drawing that's 18 inches wide. So it's on pretty big paper. And then it's 10 inches. But clearly a garage is more than 18 inches. So the scale here tells you that for every inch on the drawing, it represents 1 foot in real life. So this is an 18 foot by 10 foot garage. And then we watched this video right here on scale drawings, which you should pause this video right now and watch this video.
This is Mr. Buffington, and today we are
And you don't need to take any notes, but I would listen to this entire video. It's about 5 minutes, and it really gets you set up for this, which is what we did for the rest of the period, which was make a drawing of a room. For example, this is card 2. So I'm going to draw a room, and so I don't have the tools on here, so I have to use this tool right here. So I'll just draw right on the top of it. So if I want to draw a room, let's say I just start drawing on this grid. I want to draw it like that's the width of the room. So that is 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. So 14 units times 2 is going to be, this is a 28 foot wide room. And we'll make it kind of skinny. We'll just go 2, 4, 6, 8, 10. So 10 foot by 20, so maybe like a long storage room. And then you might want to put, like, let's say a table in here. And you want to make sure that that table is a reasonable size. 2, 4, 6, so this is like a 6 foot by 4 foot table. So that's reasonable. And so that's what we done on that page. Is just make sure that we're understanding what that meant. And then you could go on, and I checked those, and then we'd go on. And this time, notice how the scale changes. So this says draw a car, and we're using 1 unit is 1 foot. So that changes a little bit. So a typical car is going to be about 15 feet or so, about this long, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so that's a good length, and the tires are on there. So 1, 2, 3 foot tires, that's a little bit big. And so we could draw something like that and have this door. And then this would be 1, 2, 3, 4, 5, 6, 7, 8 feet tall, so that'd be about right. So wheels are a little bit big. We wouldn't have 3 foot wheels. unless they're a big truck. And notice how this is a side view. So we're just looking at it from the side, not from the top. We're not looking at it, so we're not trying to make it look three-dimensional. And the last one we got to today, well, no, we got to another. On the next one, notice how the scale really changes here on this one. And it's 1 inch is one unit is 1/30th of an inch. So this is 30 across. So this is in real life 1 inch across. And so you're going to draw a picture of a bug here. So if we've got the body of the bug and these antennae. So in real life, this bug would only be 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9/30ths of an inch wide. And it looks like about the same. So it would be maybe 1/3 of an inch wide and 1/3 of an inch both directions. So this is just looking at it from the top. And so that might be a typical little bug that is like 1/3 of an inch, like a real small. If you wanted to make a bigger bug that was like closer to an inch long, you'd use most of this paper. And then on the last one, a few people got to it. We made buildings like skyscrapers. And again, notice how 1 unit is now 30 feet. So a totally different scale so that we can take something really big like the building downtown. And let's see how tall this building would be right here. So if I made this building and we put these big windows in this big building, and I wanted to know, well, with this scale, each unit is 30 feet, so that's 30, 60, 90. So I could multiply this by 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we would do 30 times 17. And we would get this would represent a building that's over 500 feet tall. So that would be like a building downtown. I'm not sure what the tallest building downtown is, but it's probably pretty close to it. All right, and that is a wrap up for Monday, March 8th.